Today we are going to discuss numericals on vector analysis. These numericals will be based on the simple formula of vector algebra. It will be the vector addition, vector subtraction, vector multiplication, and also the uses and applications of the vectors there. So we'll start with simple numericals and also some slightly different numericals there, which you take in the general case, it will appear to be very simple there, but they are slightly tricky there. Now, before we start solving numericals there, I will suggest that you go through the entire theory on vectors. Then it will be very easy for you to understand, and you can easily apply that your concept to the different problems there. It is also, I will suggest that if you get any particular problem, you can just pause the video. Try to do that question yourself first. And then you can see that whether the way you have attempted is correct or not, or if you are getting stuck at any point, how you should proceed. So then it will help you much. So let's just start numericals on vector analysis. First question is, a vector is turned without changing its length through a small angle delta theta. What is the value of delta A vector? It is a very simple question, but a tricky one. It is said that a vector A is changing its direction. It is being turned through a small angle delta theta without changing its length. So if this is vector A, and if you just show it that it has been turned through delta theta, this is your delta A vector. We have to find the value of this delta A vector. Now, if vector A is turned through delta theta without changing its length, will it remain vector A? Remember, it is same in magnitude, but not in direction. Because if earlier the vector was A was in this direction, now it is in this direction. So here, direction has changed. So we cannot say that this still remains vector A. This will not be vector A. Let it be represented by some other vector, that is your say delta, let it be represented by vector A dash. Because if you take that one as A, then it is your vector A. This is also vector A, this is delta A, that will appear to be 0. Now, if you apply triangles law vector addition, in that case, vector A plus delta A vector, this is your A dash vector. This is vector A, this is delta A vector, this is your A dash vector. So, by triangles law vector addition, it's like this. And we can write delta A vector as A dash vector minus vector A. Here, remember that if you are representing this as A, then in that case it will appear to be 0. But delta A vector is not 0. You can see some displacement is there, some movement is there. So here, now if you look at this expression, here it is like the difference of the two vectors, A dash and A. So we can take help of the formula for vector difference there. So if you simply apply the formula for vector difference, then delta A vector in magnitude will be given as your A dash square plus A square minus 2A dash A into cos of the angle between the two. Now the angle is your delta theta, so it is your cos delta theta. So also A dash vector magnitude is same as A vector magnitude, and let it be represented as A. So what we can write here, this will be delta A vector magnitude is the square root of A square minus 2A square cos delta theta. And that can be written as your 2A square 1 minus cos delta theta. This is your 2A square. Now 1 minus cos delta theta, that can be written as your 2 sine square delta theta by 2 square root. So this will be equals to 2a sine delta theta by 2. This is your delta A vector magnitude. So this will be the delta A vector's magnitude. So only thing that you have to take care that this, when we are turning it, it will remain same in magnitude but not in direction. So these two will not be the same vector. And then only you can find delta A. Because if you miss that, you will say that this is equals to G. Next question. Two forces of 20 Newton each are represented as shown in the figure. What is the angle between them? The two forces are represented like this. These are the two forces of 20 Newton each. They are inclined like this. This is your F vector. This is your also another F. You have to tell what is the angle between the two. So diagram wise it appears it is 60 degree there. But that is not the correct one. Angle between two vectors we take as the angle of inclination of the two vectors, which is the smaller when their tails are at one point. So then we take the angle between the two vectors. Here, their tails are not at the same point. So it is not this particular angle as the angle between the two vectors. Moreover, that also you have to take as the smaller angle between the two. Because between two lines, there can be two angles. There will be two angles. So you have to take the smaller one. So what we do, we'll just redraw it. Like this one will be represented here as this particular vector F. And this is the another one, that is this vector. Now their tails are at the same point. So this is your another one. It is given that this angle is 60 degree. Now between these two F there, this is one particular angle, another is this particular angle. This angle if we take, it will be your 120 degree. This one will be the another one, that will be your 240 degree there. So this will not be the angle, the correct angle will be this one, because this will be the smaller one. Other one will be your 240 degree. We have to take the smaller angle between the two vectors if their tails are at the same point. That measures the angle between the two vectors. This is a very simple thing, but you must take care for this part. Next question. If vector A is 3i minus 2j plus vector k, vector B is 2i plus 5j minus 2k, find the following vectors and their magnitude. They are 3a vector plus 2b vector, 5a vector minus 3b vector, and vector C such that vector A minus vector B plus vector C is 0. This is a very simple question there. You have to simply find what is the sum of the vector, what is the difference of the vector. So just let's take here the first part. If you consider, you have to find suppose 3a vector plus 2b vector. So we'll first take 3 and then it will be your vector A values 2a minus 3j plus k. This is your 2 times vector B, which is your 2i plus 5j minus 2k vector. And that can be written as your 9i minus 6j plus 3k plus 4i plus 10j minus 4k. And now if this is your I and I, so just we can take it as 13i plus 4j minus k. This is your vector 3a plus 2b. If you want to find the magnitude of this one, so 3a vector plus 2b vector magnitude, this will be square root of 13 square plus 4 square plus minus 1 whole square. And that will be equals to 169 plus 16 plus 1 and that is your 186. So it is a square root of 186. So this is your 3a plus 2b vector and its magnitude. Let's take the second one. It is 5a vector minus 3b vector. So again in the same way we'll try. It is 5 times vector a, which is your 3i minus 2j plus k, minus 3. It is vector b, which is your 2i plus 5j minus 2k. So this will be equals to 15i minus 10j plus 5k minus 6i minus 15j plus 6k. So this is now 15i and 6j. So it is your 9i. This is your minus 25j. And then it is your plus 11k. So this is the vector 5a vector minus 3b vector. If you want its magnitude, it will be a square root of 9 square plus 25 square plus 11 square. So this is your root 81, 625 plus 121. And if you take this one, this will be root over 827. Similarly, as it is given a minus b plus c vector is 0 and you have to find the value of c, vector c vector. So it will be your b minus a. If you substitute the value of vector b and vector a and subtract it, you will get vector c as minus I plus 7j minus 3k. So its magnitude will be root over minus 1 square plus 7 square plus minus 3 square, which is your 1 plus 49 plus 9 square root, and that will be root 59. So this will be the magnitude of vector c, and vector c will be given as minus I plus 7j minus 3k. Next question is, if vector b is added to vector a, the result is 6i plus j cap. If b is subtracted from a, it is minus 4i plus 7j. You have to find magnitude of vector a. Second part is that vector c such that vector a plus 2c vector is equals to vector b, and d whose vector d whose x component is 6 and is perpendicular to vector b. So what is given there? If b is added to a, so if you consider vector b, vector a plus vector b, it is given as 6i plus j. Second is given that vector b is subtracted from vector a, that means vector a minus vector b. This is given as minus 4i plus 7j. So if you simply add the two, then 2a vector will be 2i plus 8j, and that will give you the vector a as I plus 4j. This is the vector a. Second case is, if you suppose subtract, in that case what you will get? If you are subtracting it, in that case 2b vector, that will be equals to 6, and then it is your plus 4i, that means it is your 10i. If you are subtracting, this is your minus 7j. So this is your minus 6j. This is your 2 times vector b. So vector b will be equals to 5i minus 3j. So now we have got the value of vector a, vector b. First part you have been asked to find the magnitude of vector a. So for first part, magnitude of vector a will be your 1 square plus 4 square root, and that is your 1 plus 16, that is root over 17. Second part is vector c such that vector a plus 2c vector is b. So vector a plus 2c vector is b. So obviously vector 2c will be vector b minus vector a. You can find this one, otherwise it is your vector a minus b, which is already given this. So I can write it as minus a minus b also. So in that case, this will be how much? This will be equals to minus 4i plus 7j, because it is your b minus a, so it will be just opposite. So in that case of vector a minus b, so this is your 4i minus 7j. So vector c will be how much? This will be minus, this will be 4i minus 7j, whole term divided by 2. So this is your 2i minus 7 by 2 j. This is your vector c. So this is how you can find vector c. Third part is there. This is suppose your first part, this is your second part. Third part is there, where you have to find vector d whose x component is 6. So I can write vector d as 6i cap. At least x component is known, but we do not know the value of y component. So let it be yj. But it is given that this is perpendicular to vector b. It means vector b dot vector d, this should be 0, as they are perpendicular, so their dot product will be 0. So now vector b, which we have taken, vector b was 5i minus 3j. D vector we have taken as 6i plus yj. This has to be 0. So this will be equals to 30 minus 3y equals to 0, or y is equals to 30 by 3, and that is 10. So this is your y component. Therefore, vector d will be how much? This is your 6i plus 10j. This will be the vector d. Next is find the value of alpha such that 2i cap plus alpha j cap plus k cap and 4i cap minus 2j cap minus 2k cap are mutually perpendicular. For doing this type of problem, you know that if the two vectors are mutually perpendicular, then their dot product will be 0. Because you know that a dot p, this is your ab cos theta, and if theta is pi by 2, in that case this will be equals to a dot b as ab into cos pi by 2, so it is 0. So the two vectors are perpendicular, then their dot product will be 0. So here also we'll use that one, 2i plus alpha j plus k, and we take its dot product with 4i minus 2j minus 2k, and this should be 0, as the two vectors are given that they are mutually perpendicular. So now it will be your 8, 2 into 4 minus 2 alpha, and then it is your minus 2. This is 0. So this will be equals to 6 equals to 2 alpha, or alpha equals to 3. So this will be the value of alpha here. Next question is find the unit vector and direction cosine of 3i plus j cap plus 2k cap. So here, if you have been given the vector, suppose a, which is your 3i plus j plus 2k, finding unit vector is very simple, because a cap will be simply vector a divided by its magnitude. So it is your 3i plus j plus 2k, and we divide it by its magnitude. So it is 3 square, 1 square plus 2 square. So this is your 3i plus j plus 2k divided by 9 plus 1 plus 4 square root. So this is your 3i plus j plus 2k vector divided by root over 14. So this is the unit vector there. Of course, you can separate the terms there. You may write this as 3 by root 14i plus 1 by root 14j plus 2 by root 14k. This is the unit vector. What is direction cosine? Because in second part you have to find direction cosine there. This is the first part there, and suppose you have to take the second part. If you consider you have a point P, this is your x coordinate, this is your y coordinate. If you take its position vector, and now it is making an angle alpha with the x-axis. So here, if it is alpha with the x-axis and it is beta with the y-axis. So cos alpha, this is called as the direction cosine of this one along x-axis. Similarly, cos beta, this will be the direction cosine along y-axis. Normally, it is represented in mathematics. If you do, it is as L, this is represented as N, M there. And if suppose z-axis is there, then we'll see how much angle it is making with the z-axis. So if suppose the z-axis is also there, suppose we take it here as the z-axis, then if this is making an angle gamma there, in that case it is your cos gamma, which will be direction cosine along z-axis. And this is represented as here. Just for two components we are taking, suppose x and y there, and if you consider here, if you just take two components, okay, like here, if I take here, this is your r vector, this is your alpha, this is your beta, this is your x, this is y. If you are dropping the perpendicular, in that case, this particular one, suppose this is the point P. Here, if I take cos alpha, this will be how much? This distance, that is your x. So it is your x by y or x by r. That is your cos alpha. Similarly, cos beta, if I take, how much it will be? Suppose I call this as y. So in that case, it is your y by r. And square it and take their sum. So that means I take cos square alpha plus cos square beta. This is your x square by r square, y square by r square. This will be equals to, how much it will be? This will be your x square plus y square divided by r square, that is your 1. So here, what you get, this is your L square plus M square is 1 if it is only two components there. If all the three will be there, in that case it is your L square, M square plus N square is 1. And what is this L, cos alpha term you are taking, which is the direction cosine? So here, as their sum, component sum is giving you one value, indirectly we can also say that direction cosines will be giving you the value of the x component, y component and z components of unit vector. So if you have to take their components, like suppose if you have got this as the components, if I square it and add, this one is added, this is added. In that case, what you will get? You will get a square of this magnitude. So direction cosine will be basically, direction cosines will be components of unit vector. So that means if you take, it is your 3 by root over 14 as the first component or component along x-axis. Similarly, component along y-axis will be how much? 1 by root over 14, and along z-axis it will be your 2 by root over 14. What we are saying, direction cosines will be the components of the unit vector. That means this one is coming in place of your x direction cosine along x-axis, this is along y-axis, this is along z-axis. So this is how you can get the direction cosine of the given vector there, which are basically the components of the unit vector. Next question. If vector A is minus I cap plus 2j cap plus k cap and vector B is minus I minus j cap plus k cap, find the magnitude of area of the parallelogram formed by vector A and B as its adjacent sides. So here you have the vector A, suppose this is your vector B, and if suppose we take this as angle between the two, then this is the this is the parallelogram, and if you want to find out area of the parallelogram area is base into height, and here this will be the height. That means if you take A cross B magnitude, this is your AB sine theta. AB is, consider AB sine theta. A is the base and B sine theta, which we are taking, this one will be your perpendicular. This is your B sine theta here. So this is your height. So this will give you area of parallelogram. This is basically one of the applications of cross product of vectors there. And you must have seen in the cross product of the vectors. You just revise that one, cross product of vector application, dot product of vectors application. You will get all these things there. So here, if I have to find this area of the parallelogram, it means I have to simply take the magnitude of cross product. So this is your vector I, j, k. It is your minus I to minus 1, 2, 1, 1, minus 1, 1. And this is the determinant. So first of all, you just take the cross product. This is your 2 minus 1 plus I cap. Then for j, it is your 1 plus 1 j cap. And for k, it is your minus 1 into minus 1, that is your 2 plus 1. And it is your minus 2. This is your k cap. So it is your 3I plus 2j minus k. This is the cross product of the vector there. So its magnitude, if you consider, this is your 3 square plus 2 square plus minus 1 square, and that is your 9 plus 4 plus 1. So it is your root over 14 units. So this will give you the cross product of the two vectors magnitude, which will be equal to the area of the parallelogram form where A and B are its adjacent sides. Basically, this is the application of cross product of two vectors. Next is you have to find the area of the parallelogram whose diagonals are given as 3I plus j plus k and I plus j plus k vector. So here the diagonals are given and you have to find the area of the parallelogram. So suppose you have the vector A here. This is another vector B. If you complete the parallelogram, that means this is also vector B, this is your vector A. One of the diagonal, we can represent it as this. This is suppose your D1. This is your another one, this is your D2. So here, if I consider that for this one, I can write the vector A plus vector B. This is your D1 vector. And if suppose now I take this triangle, so it is vector A plus D2 vector. This is your vector B. If I take help of this particular triangle and we apply triangle slope vector addition. So now you have here a D2 vector as vector B minus vector A. And vector B1 was your vector B plus vector A. So if you simply add, in that case, what you will get? Vector 2B vector will be equals to D1 plus D2 vector. And that will give you vector B as D1 plus D2 vector divided by its magnitude. If you take the difference, In that case, suppose I take a second one and subtract it from the first one. In that case, how much you'll get? 2a vector. This will be your d1 minus d2. If you just subtract from this one, so this will give you vector a as d1 vector minus d2 vector divided by 2. And now, as you know that we have to take the cross product there. So area of the parallelogram, this is your A cross B vector's magnitude. So first of all, we'll find the cross product and then we simplify this one. Now here, if I just substitute the value of d1 and d2, so d1 is your 3i plus j plus k, and this is your I plus j plus k divided by 2. So this will be equals to, this is your 4, that means 2, this is 2, 4, 2i plus j plus k. This is your vector b, and d1 minus d2 will be your 3i minus 3i plus j plus k vector minus I plus j minus plus k vector. You have to take the difference divided by 2. So this time it will be equals to 2i vector by 2. It is I because j and k components will just get cancelled. So in this case, if you consider the cross product, vector A, first of all, it is ij, like here I am taking A cross B. So it is your I, j, k. And for the vector A, it is your 1, 0, 0. This is your 2, 1, 1. So here for I, if you consider, it is your 0 minus 0. So first term will be 0. Second term for j, it is your 0 minus 1. This is your j. And for k, if you consider, because it is your 0 minus 1. For k, it is 1. So that means this is your minus j plus k vector. And now if you take its magnitude, how much it will be? The square root of minus 1 square plus 1 square, and that is equals to 2. So this is the area of the parallelogram. There is one shortcut method also to find this one. Area of the parallelogram is half the magnitude of cross product of diagonals of the parallelogram. That means if I take d1 and d2, which are the diagonals, so we take their cross product, we find this d1 cross d2, area of parallelogram will be equals to half magnitude of this d1 cross d2. Let's see this one. If I take a d1 cross d2, in that case, this is your I, j, k, and this is your 3, 1, 1, 1, 1, 1. If you again expand this one, for I, if I am expanding, it is your 1 into 1 minus 1 into 1. So it is your 1 into 1 to I cap. Then for j, it will be your 1 minus 1 into 3, j cap. For k, this row and this column will be eliminated. It is your 3 minus 1 k cap. So this is your minus 2j plus 2k. This is the cross product there of d1 and d2. Now here, if I take their magnitude, that means the area of the parallelogram, this will be a square, this will be half of magnitude of D1 and D2 cross product. Okay, so that means this is your half. It is the square root of 2 square plus 2 square, which is your 4 plus 4, a square root divided by 2 over 2. Next, you have to find volume of a parallelepiped whose sides are given as vector A as 2i plus 3j, vector B is I plus j plus k, and vector C is 2i minus k cap. Now, the volume of a parallelepiped is given by the scalar triple product. If three vectors are there and we take their scalar triple product, that will give the volume of the parallelepiped. Like here, I can take suppose A cross B, and the dot product of this is taken with C. So this is called as a scalar triple product. That means you take the cross product of the two vectors and take the dot product with the third vector. So this is there. Or you can take a vector A and B and C cross product we are taking, and we are taking dot with vector A. So this is basically a scalar triple product. Why it gives the volume of a parallelepiped? Because here, if you consider that the three vectors are there, which we are representing them as a vector A, say this is your vector B, this is vector A, and there is another vector, suppose it is your C vector. A cross B vector, it will give you the area of the parallelogram. This is your A cross B in magnitude. And what will be its direction? Its direction will be perpendicular to the plane containing these two vectors. And now you are taking its dot product with vector C. So what it will give you? It will just give you the component of this one in its direction. This will be basically giving you projection of this one in its direction. That means this is the base. This projection will give you the height. So this will be the base into height. That will give the volume of the parallelepiped. So you have to find the volume of the parallelepiped for this one. So in that case, the scalar triple product A, B, C, if you consider, in that case, this is given as, first, it will be just the components. Like for the cross product for B and C, the first row was your I, J, K, and then it was your, for B cross C, it will be B1, B2, B3, C1, C2, C3. And now you are taking dot product with A. So corresponding terms will be multiplied there, like X component. So it is your A1 I will be multiplied by this I dot here, whatever coefficient we are getting. So basically this one will be now coefficient of first vector A. So it is your 2, 3 and 0. Because vector A is 2i cap plus j cap. Vector B is your 1, 1, 1, and this is your 2, 0, 1. So we have to basically expand this determinant. So now if you expand it, it is 2. It is your 1 minus 0. For 3, it is your 2 minus 1, and third term is 0. So it is your 2 plus 3, that is 5 units. So the scalar triple product or the volume of the parallelepiped will be equals to 5. So this will be the volume of the parallelepiped. We just take that scalar triple product is determined, and that one will give the volume of the parallelepiped. Here, if it is asked that three vectors are given, you have to show that they are coplanar. Then what will show? Will show that the volume of the parallelepiped is 0. Because if all are lying in the same plane, then corresponding height will be 0 there. So in that case, they will be giving you the volume of the parallelepiped 0. So for proving that three vectors are coplanar, you simply show that their scalar triple product is 0. Next question is, determine the vector which when added to the resultant of vector A, which is 2i minus 4j minus 6k, and vector B, 4i plus 3j plus 3k, gives unit vector along z-axis. So it is given that you have to find a vector which, when it is added to the resultant of vector A and vector B, this gives a unit vector along z-axis. So here, let D be the required vector. So it is your D plus vector A plus vector B. This is the resultant which is given as the unit vector along z-axis. So it is your k cap. So it is your D vector plus vector A, 2i minus 4j minus 6k plus 4i plus 3j plus 3k. And this will be how much? This is your vector k. So vector D, this is your 6i minus j minus 3k equals to k. Or if you transfer it on the other side, vector D will be equals to minus 6i plus j plus 4k. This 3k and this k will get added, so it will be giving you this as the resultant. This is the required vector. Next question. If 0.5 I cap plus 0.8 j cap plus c k cap is a unit vector, find the value of c. So it is given that this is 0.5 I plus 0.8 j plus c k cap. This is a unit vector. Okay, this is the unit vector. So if it is a unit vector, it means what we can say that it is a 0.5 whole square plus 0.8 square plus c square is square root. This should give you 1. That will be the magnitude of this vector. And since it is unit vector, its magnitude will be 1. So it will be your 0.25 plus 0.64 plus c square. This is your 1. If I square and add both sides, so this is your 0.89 plus c square is 1, or c square is 1 minus 0.89, that is your 0.11. So c will be the square root of 0.1. This is the value of c. Only thing what you have to see that as it is unit vector, the magnitude of this one will find, and this should be equal to 1. And from that we can get the value of c. Next question, which is very common there. Find the component of vector A, which is equals to 2i plus 3j along the direction of I plus j cap and vector I cap minus j cap. So here you have to find the component of the given vector in the direction of some other vector. Again, this is the application of the scalar product of vectors there. So there, if you consider like you have the vector A, and I want to know the component of the vector in the direction of the other vector. So if you consider a scalar component of vector A along vector B, if it is a scalar component, it will be simply given as A dot B divided by the magnitude of vector B. That means the vector in its direction we want to find component, we divide it by its magnitude. If it is your component of B along vector A, then it will be your A dot B divided by magnitude of A. Whereas if you take the vector component of vector A along vector B, so it will remain A dot B by vector B magnitude. Only thing is that now this time it will be multiplied by unit vector along the direction of vector B. So it will be the unit vector. because you are taking the vector component. And where you are taking it along vector B. So obviously this one will be multiplied by magnitude by the unit vector B here. So let's take a scalar component of 2I plus 3j along I plus j vector. Okay, so this will be how much? This will be your dot product 2I plus 3j dot I vector plus j vector and divided by the magnitude of this vector, because we want it along I plus j vector here. So it is your 1 square plus 1 square. And this is your 2 into 1, that is 2 plus 3 divided by root 2. So it is your 5 by root 2. So this is the scalar component of vector 2I plus j along vector I plus j. If you want its vector component, so vector component of 2I plus 3j along vector I plus j. Now what will be this? This term will still be there. So in that case, it is your 5 by root 2 multiplied by the unit vector along this direction. So it is your I plus j vector divided by its magnitude. So it is your 1 square plus 1 square. So this is your 5 by 2, because it is again root 2 here. It is root 2 already there. So it is your I plus j. So this will give you the scalar component and this is the vector component. Similarly, for the second case, a scalar component of 2I plus 3j along the second one, that is your vector I minus j. This will be equals to 2I plus 3j and you take the dot product with I minus j divided by the magnitude of this I cap minus j cap. So it is your 1 square plus 1 square. And this is your 2 minus 3 by root 2. So it is your minus 1 by root 2. And if you take the vector component, in that case, this will be minus 1 by root 2. And now we'll multiply it by the unit vector along I minus j. So this is your 1 by 2 I cap minus j. So this is how we get the component of the vector. If it is a scalar component, you will simply take the dot product divided by the magnitude of the vector along whose direction you are finding the component. If it is the vector component, it will be again dot product divided by the magnitude of the vector along whose direction you are taking the vector or the component, and you multiply that quantity by the unit vector along that direction. So this is how you can find a scalar and vector components. This is another question which is slightly tricky there. If vector A, B, C are the unit vectors such that vector A plus 2 times vector B plus 2 times vector C is equals to 0, find the value of magnitude of A cross C. A, B, C are the unit vectors. One condition is given that vector A plus 2 times vector B plus 2 times vector C is 0. You have to find the magnitude of the cross product of A and C vector. So how will proceed? It is given that vector A plus 2 times vector B plus 2 times vector C is 0. Remember, you have to find cross product of A and C. So somehow we should have the terms A and C there so that we can take their cross product. So let's see this. This is vector A plus 2 times vector C. It can be written as your 2 times vector B. Suppose here we take the square of that. That means we are taking the dot product with the same vectors there. So that means here I can take vector A plus, and we take its dot product, vector A plus 2 times vector C. This is now your 2 times vector B dot 2 times vector. So this is how much? This is your A square, it is A dot A. Then it is your 2 times, there will be your vector A dot vector 2C. Then it is your 2C vector dot vector A plus 2C vector dot 2C vector. This is equals to 4 times B square vector. So again, this can be written as your A square plus this will be your 2 AC cos theta. This is also 2 AC cos theta, and this is your 4C square, that is your 4B square. Remember that A, B, C all are said that they are the unit vectors. So as they all are unit vector, their magnitudes will be 1. So this will be your 1 plus this term will be your 2 cos theta. This is your 2 cos theta. This is your 4 equals to 4. So what we get? 4 cos theta. This will be equals to how much? This side. So it is basically minus 1. So 4 cos theta is minus 1. So cos theta term is minus 1 by 4. Now what you have to find? You have to find magnitude of A cross C. So it will be your AC sine theta. A and C are the unit vectors. So that will be your 1. And now we have to get the value of sine theta. Sine theta, what we can write? A square root of 1 minus cos square theta. So this will be equals to root over 1 minus. How much is your cos square now? This is your 1 by 4 whole minus 4 whole square, that is 1 by 16. Because you are taking cos square theta. So this is how much? Root over 15 by 16. This will be the value of the magnitude of cross product of A and C. So what is there? Of course, if you directly try to get the value of A cross C there, in that case you will get trapped, because then either you will have to take how we are getting that particular term there. So it is best that we can get it there for cos theta term, and then we can substitute in the formula which is required there. So this is how you can solve this problem.